Hello, students. Let me start with a simple thought. When you drop a piece of sodium metal into alcohol, you get some fizzing. But if you try the same with a carboxylic acid, the reaction is much more vigorous. Why? Because the carboxyl group, COOH, is strongly acidic. Carboxylic acids, just like alcohols, can liberate hydrogen gas with electropositive metals. But here's the difference. Unlike phenols, they can even react with weaker bases such as carbonates and bicarbonates. And this reaction is actually used as a functional group test. The effervescence of carbon dioxide gas confirms the presence of a carboxyl group in the compound. So, the very acidity of COOH is the key identity marker of carboxylic acids.
Now picture this. Take acetic acid, that's CH3COOH, and add sodium metal. Immediately, bubbles of hydrogen gas appear. The balanced reaction goes like this. Two molecules of a COOH react with two atoms of sodium to form two molecules of a COONA and one molecule of hydrogen gas. Sodium carboxylates formed in this reaction are stable, water-soluble salts. The visible effervescence of hydrogen is a clear indicator of acidic behavior. It's an easy lab test that instantly distinguishes a carboxylic acid from neutral organic compounds. Let's step into another reaction. If you neutralize a carboxylic acid with an alkali like sodium hydroxide, you get a simple salt and water. For example, HCOOH plus NaOH gives us COO plus H2O. This is a straightforward neutralization reaction, but it tells us something important, that COOH group is much more acidic than alcohols and reacts completely with bases. The salts formed here are crystalline, stable solids, often used in industry as intermediates. The heat released during neutralization also proves the strong acidic nature of carboxylic acids. Here comes the classic effervescence test that every organic chemistry student remembers. Carboxylic acids react with carbonates and bicarbonates, releasing brisk effervescence of carbon dioxide. For example, HCOOH plus Na HCO3 forms up COONA, water, and carbon dioxide gas. The appearance of bubbles is a simple but reliable diagnostic test in labs to identify acids. Unlike phenols, which fail to react with weak bases, carboxylic acids are acidic enough to displace carbon dioxide even from sodium bicarbonate. This difference makes the test an easy way to confirm the carboxyl group. Let us now look at what happens in aqueous solution. Carboxylic acids ionize to form hydronium ions and carboxylate anions. The general equilibrium is at COOH in water forming at COO- and H3O+. But here's the fascinating part, the carboxylate ion is resonance stabilized. The negative charge is delocalized over two oxygen atoms, making the anion far more stable than the simple alkoxide ion you get from alcohols. This resonance stabilization is exactly why carboxylic acids are stronger acids than alcohols. The hydronium ion released explains their acidic properties in water. Let's wrap this up with a comparison that often appears in exams. Ethanol, that's CH3CH2OH, and acetic acid, that's CH3COOH. Ethanol dissociates to give an ethoxide ion, CH3CH2O-, which is highly unstable because the negative charge is stuck on a single oxygen. In contrast, acetic acid dissociates to give an acetate ion, CH3COO-, where the charge is beautifully shared by two oxygen atoms through resonance. This stabilization makes acetic acid far more acidic than ethanol. The takeaway? Resonance isn't just a drawing trick, it's the core reason behind the acidity of carboxylic acids. So, to summarize, Carboxylic acids are stronger acids than alcohols because their conjugate base is resonance stabilized. They react with metals to release hydrogen, with alkalis to form salts and water, and with carbonates or bicarbonates to release carbon dioxide, a quick laboratory test. In water, they ionize into resonance-stabilized carboxylate ions and hydronium ions, explaining their acidic behavior. I hope today's session has helped you see that every fizz, every bubble, and every salt formed is proof of the hidden power of the COOH group. Chemistry is truly about these invisible interactions that explain the visible world around us. See you in the next class with more exciting reactions and real-life connections.